Alright, so next I would like to go over homework 1, question number 7. Homework 1, number 7. Okay, in this question it states that you are asked to load 10 boxes of nails, each weighing 100 newtons, onto a truck. The bed of the truck is 1.4 meters above the ground, and there are 2 different boards near the truck, a 4.6 meter long board and a 2.3 meter short board. A. What is the mechanical advantage of each board? B. How much force is required to move the boxes into the truck with each board? And C. Which board would you want to use, the long or short board, and why? Alright, so the first thing I'm going to do is draw my picture. So I have a truck. Alright, and the truck is 1.4 meters above the ground, the truck bed. I have 10 boxes of nails. And each box is 100 newtons. So that's going to be my force out. That's what I want to happen. I want this 100 Newton box to move. Now, we could do, I know the homework one is called levers and torque, but then right above it says simple machines. So, I mean, all the types of simple machines are fair game in these questions. If I tried to use, a lever with those boards, I would have to make sure the lever could move up and down 1.4 meters, so that the box ended up level with the truck. So I would have to make sure the fulcrum is in the right spot, so my output distance lifted up 1.4 meters, and then I would have to figure out what my input distance could be to measure how much force I could apply to it. And that's just a lot of work, and you weren't really given enough information to do that. So instead, we are going to use a ramp. So I want to place those boards to make a ramp, and I'm going to take my boxes of nails, and I want to be able to push them up the ramp as efficiently as possible. So part A, what is the mechanical advantage of each board? So if you remember, mechanical advantage is equal to distance in divided by distance out. Okay, and brush keeps changing. So for board 1, I'll make these boards in different colors. There we go. For board 1, the long board, my mechanical advantage is going to equal the distance in. The distance in is the length of my ramp. Okay, and for question 1, the long board is 4.6 meters. That's divided by my distance out. My output distance is still going to be this 1.4 meters. That's how high I want my ramp to go. Okay, meters divided by meters. The units go away. Mechanical advantage is a ratio, so it doesn't have units with it. 4.6 divided by 1.4 gives me an answer of 3.29. So the mechanical advantage of the long board is 3.29. Now for the short board. Mechanical advantage is going to equal my distance in, and the length of my short board is 2.3 meters. And my output distance is still the 1.4 meters. So even though it's a shorter board, I still need to go just as high. Again, my meters cancel out. And 2.3 divided by 1.4 gives me a mechanical advantage of 1.64. Now, just in the last video about pulleys, we talked about the higher the number of the mechanical advantage, the better the advantage is. So in this case, the higher number is going to be my long board. Okay, the next question. How much force is required? So let's see, I'm going to get rid of a couple things here. There we go. I'm just going to erase my boxes here. Okay, so now that I know my mechanical advantage, it's going to go to the long board. Mechanical advantage is also equal to force out divided by the force in. Okay, and I know my mechanical advantage. So for the long board, mechanical advantage equals force out divided by force in. My mechanical advantage is 3.29. So 3.29 equals force out. My output force is the force on the boxes, which was 100 newtons. Force in is what I have to push with, and I don't know what that force is yet. So if I multiply both sides by force in, those go away. And if I divide both sides by 3.29, my force in for the long board is going to equal 100 newtons divided by 3.29, which is a unitless mechanical advantage. So I end up with a force in of 30.4 newtons. Now let's do the same thing for the long board. My mechanical advantage is 1.64. That's going to equal my force out, which is still 100 newtons. It's the same box of nails, divided by my force in. So then force in is equal to 100 divided by 1.64. Which gives me 60.97. So I'm going to round that up to 61.0 newtons. So here's part B. Here's part A. And then for part C, which board would you want to use, the long or short board, and why? And believe it or not, there are different answers here. Maybe you want a better workout. Okay, so your reasoning will determine which board you'd want to use. If you're trying to be more efficient and save energy, then you'd want a different board than the one you'd want to use to get a better workout. So hopefully that helps with those questions. If you need more assistance, please let me know, and I will make more videos.